What if your strategy presentation could turn into working software in just a few structured steps? I will show you in this video how a custom data and AI use case management app can emerge directly from a strategy deck, like a normal strategy presentation. We will use Miro AI flows, Miro MCP, connecting with Lovable, and human voting. Just a bit context first. Most enterprises manage AI use cases in SaaS tools. They collect proposals, define criteria, calculate scores, and rank what to do next. The problem? Strategy adapts to the tool, and the criteria are rarely derived from the actual strategy. We want to flip that logic. First, we want to have the slides. Then we want to define OKRs, objectives and key results. From there, we want to further derive prioritization criteria. And then we want to have a dot voting as a human in the loop. And finally, we will be able to wipe code the app using Lovable. All in one flow. Here I show you now how it works. Let's move in. Okay, you see here the strategy deck. In this example, we used the Mitsubishi Strategy 2027 because it's a publicly available example, and it looks quite like a standard strategy. We first then use a Miro AI flow to extract this doc file. This is a catalog of objectives and key results. I won't go into the detail right now, and I also won't do the AI flow because it takes some time, but want to move further on with the second flow, which is designed to use the then existing OKR catalog to derive and extract 30 prioritization criteria. I also tasked the AI to extract some more context information. For example, the definition of this criterion and why it actually matters inside the strategy. Also, we use 3 categories. I will explain this now. We want now to have a voting because we want to further reduce the number of criteria to 6. And within the Datentreiber method, we always use a triad of business understanding, user understanding, and data understanding. And this is represented here with those 3 categories: viability, desirability, and feasibility. I also used here this AI gimmick, the AI action button, to extract every cell from every row in the column criterion, because those are the names of the actual prioritization criteria. Then next is a voting, a dot voting, which is performed by humans, usually more than one, of course. I did it now just to exemplify how this could look. Well, the goal is then to again move to an AI flow, the third one, and the task of this AI flow is to check in each category for 2 winning sticky notes, and therefore prioritization criteria. This means this AI flow will check and select the two most voted sticky notes. If there's a tie, then it also can bring in three. Um, and now the final step, we hand off again to the AI, but now in form of the model context protocol. Um, we established two kind of static artifacts. One is a very long and sophisticated master spec. Here we define everything how we want Lovable to build the app, like the structure, what features we want, how the JSON structures should be defined, and it's very detailed. But also, um, we will build in a scoring model, and this is actually connected to the strategy specific input that will go into the Lovable app, because here we have a dynamic content. Those criterias will always change based on what was the initial strategy or how the voting went. So we will never know what are the actual criterias that the people will choose. And therefore, we have this scoring rulebook, because we kind of need a framework for for Lovable to understand how to actually derive a numeric mathematical model from pure names, from pure semantics. Building the app starts when I click this green button. Then Lovable will be called and will start to pull from the Miro board. Usually, Lovable pulls or can pull from all of the context, which means everything that is on the board. I, however, used the Miro REST API to code a very small a custom code snippet that sends an initial system prompt to the Lovable app to instruct it to only look for the frame named Lovable and only fetch data from here. So the goal is to have it more clean and easier for the model. The result is then finally here. You see there's this app. It is actually, I mean, yeah, you can see there's a very there are lots of features actually. And also we have an in-app AI, which enables a mapping from normal plain English, like you describe your use case idea, onto the structure of the use case catalog. And of course, we have the scoring, and therefore it would be a ranking if there would be more use cases. All right, I think this is the overview. I will hand it off from here. Thanks for watching.